Hi, so we're going to start our new unit. We're going to start talking about in this unit about things that are not the same size, same shape, but things that are the same shape but two different sizes. And in order to start that, I need for you guys to remember some stuff that you learned a long time ago back in the world of pre-algebra, a little bit in algebra about proportions and ratios. And so what I have for you is three proportion and ratio problems. And I want you in your groups or with a partner to give your best effort to do these problems by yourself. And we'll pause the video and then we'll come back and look at them and see how you did. Okay, so in this first one, we're solving for x. There's two different strategies you could have used for this. Some of you maybe cross multiplied. You said 6 times 11 is 66. X times 2 is 2x. You equaled those cross products and divided by 2 and got x equals 33. Others of you used a more proportional reasoning to work this problem. You said 6 divided by 3 is 2. So what divided by 3 would be 11, and you said, oh, that must be 33. Either way, 33 was your answer. On the next one, write the ratio. Remember, a ratio is just a comparison of two things. So the ratio, oh my goodness, I miscounted, of circles to squares, that's 4 circles compared to 5 squares. And on the last one, write the ratio of a cup of milk to a gallon of milk. Well, keep in mind that if I just say 1 cup compared to 1 gallon, that doesn't really tell me how those two things compare in size. And so what I need to do to compare those in sizes is I need to put them all in one unit, the same unit, to really be able to compare them. So I'm going to say 8 ounces is to 128 ounces, and then we're going to reduce that fraction. 8 goes into 128 16 times, so that would be a ratio of 1 to 16. And you don't even need units on that. The units essentially cancel out for that ratio. So for every 1 cup, you have 16 of those cups in a gallon, essentially, is what we're saying by that. So let's talk about what a ratio is. So just a reminder here, a ratio is a comparison. And sometimes, or comparison of two things, two quantities, sometimes you write it as A to B, the word to. Sometimes you do it A colon B to compare them, to show that you're comparing. Or some people write it as a fraction, A over B. That's what we'll do the most in this class, is write it as a fraction. But keep in mind, it's technically not a fraction. It's a comparison of the numerator to the denominator. All right, so just like 3 to 4 can be written as 3 colon 4 or 3 over 4. And we use these ratios anytime you're zooming in or zooming out on a picture. If you want to exchange money, go into a foreign country. If you want to do a scale model or a map, just like we're going to do with our house project, will be a scale model of your actual house in real life. When you go to look at colleges in the next couple of years, you're going to be real interested in that teacher to student ratio. You know, are there 300 students for every one teacher, or are there 14 students for every one teacher? Here at Episcopal, I believe it's an 8-to-1 ratio, 8 students for every one teacher. So it kind of tells you like what size your classes are going to be. And so that's helpful when you're looking at colleges. You'll also want to look at, when you go to colleges, you know, what's that girl to boy ratio? Are there 5 girls for every 1 boy? Is that something I want? Is that something I don't want? And then, of course, sports. You know, you're looking at how many hits versus how many misses, or wins versus losses. We use ratios a ton in sports. All right, so let's practice. Our first one actually is a sports ratio. Let's practice writing the ratio of touchdowns per game for a tight end. So the ratio of touchdowns per game. So how this works, in case you've forgotten, whatever comes first in the ratio, that goes in the numerator. and whatever comes second, that goes in the denominator. So you read these from left to right, first numerator, second denominator. So touchdowns, TDs, are going to go on top. Game is going to go on bottom. So we're talking about 6 to 14. And then, of course, we always want to reduce our fraction. So that's going to be 3 touchdowns per 7 games. And then there's also something you learned about back in 6th, 7th grade about what's called a unit rate. So if you wanted to figure out the touchdowns per game, you could actually convert this to a decimal so that that denominator would be 1 on the bottom, and that would tell you how many touchdowns you make in each game. Okay. In the second example, we have more of a geometric example. If I want to find the ratio on the number line of me, the distance from M to E, compared to yo, the distance from Y to O, right? Then you're talking about a distance of 10 compared to a distance of 20. 10 to 20 is going to be a distance of, or a ratio of 1 to 2. Okay, and you can also write these ratios as decimals if you want. Okay, so at the top of the next page, we have the ratio. The weight of a car is going to go on top because it came first. The weight, that is, of the model car is going to go on bottom because it came second. So we're talking about 2,900 pounds compared to 8 ounces. Now, again, telling me that this car is really, really big and that this model car is really, really small, that's no shocker. But that still doesn't tell me how many of those model cars would fit together to make a actual car. So I need to be able to compare these. And right now they're not in a comparison situation. So what we're going to do is we're going to convert the pounds to ounces. Remember, you can also convert ounces to pounds. It doesn't matter what unit you're in, but you need to convert to 1 unit when writing a ratio. I didn't erase my wheels there. All right, so I'm going to go ounces to pound. I'm sorry. Oh, yeah, let's go ounces to pounds because there's 16 ounces in a pound. And so check this out. If there's 16, 8 is half of 16, so I can just say 0.5 ounces down here. I'm sorry, I did that wrong. 0.5 pounds is what 8 ounces would be, and 2,900 pounds is what I have on top. And then let's just convert this to a nicer number. Okay, so do our calculator and we say 2,900 divided by 0.5 to reduce that fraction. It's essentially dividing by 1/2, flip and multiply. You're multiplying by 2 is essentially what you're doing. You get 5,800. So there's 5,800 of those model cars in one of the big cars. And that would be our ratio. Now, important, the 1 must be there. Because remember, this is a comparison of 2 numbers. So if I don't have a number in the denominator, then what am I comparing? So make sure you do write that 1, even though normally when we're writing a fraction, that would be understood. All right, ready? You try. Pause the video and come back and we'll check your work. Okay, so you should have written 168 on top because it came first, 8 on bottom because it came second. 168 over 8, 8 goes into 168 21 times, so 21 to 1 would be your ratio of how many of those model cars fit in an actual car. All right, so I'm going to stop this video and we can pick up in the next video talking about the golden ratio.